Satu, dua, tiga dicoba. Cek satu, dua, tiga dicoba. Cek satu, dua. Cek satu, dua, tiga dicoba. Satu dua.
Assalamualaikum, Prof. Suhaidi.
Waalaikumsalam warahmatullah. Dr. Agus, how are you?
Alhamdulillah. Good. How are you, Dr. Professor?
Alhamdulillah, khair. Bagus. Uh, Boleh saya cuba untuk share the slides? Just boleh dengar ya? Dapat dengar ya? Can you hear me?
Yes. We can hear you.
Yeah. Just want to share try to share my slides. Saya cuba mau apa ni share the slides-nya.
So, that's good. I think you can share your PowerPoint, Prof. We already open share access. We already allow you to share presentation.
Yeah, wait a minute ya.
Can you hear our voice from here, Professor?
Wait a minute.
Good morning, Professor Suhaidi. Can you hear my voice?
Yeah. I can hear your voice. Can you see my screen?
Yes, we can see your presentation. It's already, yeah, nice picture.
Boleh dapat kah? Can you hear?
Yes.
I cannot hear you very well. Dr. Agus?
Yes, Professor. Okay.
Hello?
Yes, I can. We can start from now. Good morning, very good morning, our students. Now we are going to attend a presentation from Professor Suhaidi Hassan. He is a professor from University Utara Malaysia. Yeah, and he provide his time and want to share the experience about IoT, what we have studied for this semester. So time is yours, Professor Suhaidi. Please, yeah.
Yeah. Okay, I hope everyone can hear me very well.
Yeah, yes, very well. Now, your voice is very nice, clearly.
Okay, yeah. Okay, أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين وبه نستعين على أمور الدنيا والدين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. سبحانك لا علم لنا إلا ما علمتنا إنك أنت العليم الحكيم. ولا حول ولا قوة إلا بالله العلي العظيم. Assalamualaikum warahmatullahi wabarakatuh. and very good morning to everyone. First of all, I would like to thank Dr. Agus Sofyan for inviting me for this lecture. So, my name is Professor Dr. Suhaidi Hassan. I'm from University Utara Malaysia. University Utara Malaysia is located on the border of Thailand in the northern part of Malaysia. Before, okay, our topic today, I have been given 2 sessions from Dr. Agus, excuse me. 2 sessions, The first session is today, and the next session is on the 29th of September. So the first session, in these 2 sessions, we will talk about the IoT communications in the 6G era towards an intelligent network computing environment. First of all, I would like to introduce a little bit about myself. I'm previously working, now is in the process of retiring. I'm the Professor of Computing Network in School of Computing, University Utara Malaysia. I have my educations in computer science from State University of New York in Binghamton, New York. And I have my master's degree in information science with concentrations focused in telecommunication and networks. And my PhD or S3 in computing networks in University of Leeds in United Kingdom. I was serving as the Assistant Vice Chancellor of College of Art and Sciences in UUM. And I have previously served as the former Dean of the Faculty of Information Technology in university. Outside the academia, I also I was the past president. I'm the past president and founding member of Internet Society Malaysia. So Internet Society Malaysia is the non-profit organizations, and it is part of the Internet Society Global. So you can be a member of Internet Society Global, and it is free to join. So Internet Society is the organization which is important for the internet development. Because under the Internet Society, we have the structure we call the IETF, Internet Engineering Task Force, which is responsible to create the standards for the everything about the internet. So if the standard is not approved by the IETF, then the particular software or particular protocols, for example, will not be able to be executed on the internet. So this is also relates to the IoT, because there are many IoT related protocols which are approved by the IETF. So you can be a member of Internet Society, and you can even create a chapter of the Internet Society in Semarang. So I can always help if you need more information on this. I also involved in the organization called ICANN, Internet Corporation for Assigned Name and Numbers. ICANN is a very important organization for the internet as well, because it administers the names and numbers. The names. For example, if you want to use your domain names, you need to somehow connect to ICANN. Yeah, you buy the domain names from the any reseller, domain name reseller, or you buy it and then you use it. Yeah, for example, blah 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 dot co.id, for example. Yeah, and then or something.com. Yeah, or nowadays they have what we call it uh, generic domain names. Yeah, so you can buy, for example, .lawyers. Yeah, .tv. Yeah, and so on. So this is actually the task of ICANN. Yeah, so not only that. Yeah, every domain, every host on the internet is need to be equipped with need to be put with the IP address. Yeah, so IP address is also somehow, yeah, is administered by the ICANN. Yeah, is governed by the ICANN. Yeah, through what we call the regional internet registries. Yeah, for the Asia Pacific. Yeah, we have APNIC. Yeah, the Asia Pacific Network Information Center. Yeah, the headquarters in Australia. So everything need to be addressed properly, yeah, in the internet. Otherwise, we cannot communicate the internet. Otherwise, the IoT will not be able to be communicated through the internet. So ICANN is a very important organization because ICANN govern the names and numbers of the internet. So you can get involved in ICANN ecosystems. Yeah. So I am one of the ambassadors of the ICANN, what we call APIRALO, the Asia Pacific Regional at Large Organizations. And we actually represent the users of the internet. Yeah. In ICANN ecosystems. So ICANN has meetings every year, and there are at least three meetings, and we as users of the internet can attend any of the meetings. Yeah, of ICANN. Yeah. So it has also opportunities for students. Yeah, for example, for lecturers to be fellows of ICANN. Yeah. So, for example, this coming meeting in Dublin in October, there are opportunities for people to be selected as the next generation leaders of the internet. So you can go to the website of ICANN and you can apply to be to get involved as the leaders, as the practitioners, yeah, as the scientists, yeah, to get involved with the activities. Before I forget, the IETF as well is also open for everyone to participate. Yeah, I myself is a fellow of the Internet Engineering Task Force, so you can attend the Internet Engineering Task Force, yeah, to get involved in the process of developing the internet standards, yeah, including that of those of the Internet of Things. I'm now serving as the honorary professor in the University Utara Malaysia, and I have been with the University Utara Malaysia for the past 34 years, since 1991. I have supervised PhD students, yeah, 30 PhD students who has completed under my supervisions, and those from 20 countries. Yeah. So Alhamdulillah, I'm also helping universities, including those in Indonesia, collaborating with many universities, including what I'm doing now today. Yeah, thank you, Pak Agus. I also serve as the visiting as the adjunct professor in Universitas Sumatera Utara for the past 1 year. And recently, last week, I was visiting Universitas of Riau in Pekanbaru, also to give similar or some related research presentation over there. So let's get into our business today. Our lecture agenda, according to the topic given to me, Dr. Agus asked me to give a lecture on the IoT communications in 6G, and we want to talk about the intelligent network computing environment. Yeah. So I divided the lecture into two parts. Yeah. The first session today, we're going to talk about the IoT communications. Yeah, IoT and IoT communications. And we give some backgrounds in that. So I'm sure many of you have gone through all these topics, but this is, if you want to regard it as a review, but this is also important because we need to understand the whole ecosystems of the IoT before we can go to discuss about the intelligent network computing environment. Which we will talk on the 29th of September, inshallah, next week. Yeah. So today we also, in addition to IoT communications, we will talk also a bit about the 6G. Yeah, the 6G, the 6 generations of wireless cellular networks. Yeah. So we want to talk about this technology, yeah, about the wireless cellular technology, yeah, and we have the evolutions, yeah, from the 1G, yeah, toward the 6G, yeah, and what is the difference between the 6G communications with the previous 1 to 5G communications. So we'll cover a little bit about that. Yeah, the 6G network is not yet here. It's not yet operational. It is still in the lab. Yeah, it's still in prototyping and also in the domain of research. Yeah. Even 5G is not fully deployed. Yeah. Now it's being deployed rapidly, and we are expecting the 6G, yeah, to be deployed somewhere in 2028. Yeah, 2028. So the thing is that the IoT communication is very much optimized in the 6G communications, yeah, in 6G era. So we will talk about that perhaps in the second week, next week, yeah, inshallah. So in the second week, which is on the 29th of September 2025, what we're going to talk will be about the 6G intelligent network computing environment. We want to talk about how IoT work hand in hand with the big data and also the AI, yeah, to create what we call it the network intelligent environment. And also next week, we're going to talk about the industrial, the research, and the societal and also economic implications of the 6G communications. Yeah. So this is hopefully will happen next week. Yeah, inshallah. The same time, yeah, Prof. Dr. Agus, yeah? Inshallah. So far, can you hear me very well there? Am I speaking too fast or what? I can blend with the Indonesian language, but in case we have participants who are not speaking, do we have international students? It's not Indonesian, or we can mix. Dr. Agus? So is it okay? Is my English is okay? Can you hear me? Can you hear? Hello? I cannot. Hello, Dr. Agus? Okay? Yes? All right. Okay. Let's move on. I like to use these slides, to highlight the evolutions toward the connected intelligent network. So I think I've shown this slides when I was in Undip a few years back, in the conference. But I want to highlight this again, when we talk about communications, previously in the 14th to 18th century, we are communicated with our partners around the world through the sea routes, so we have different routes that cover the distant land, For example, we are in the Nusantara. We connect the people from the east and the west, So the east and the west uses us, For example, from China to India, So communication is very, very slow, but it works, and it works until today, that we use this medium, the sea, as a medium for the communications. But later, when we advance, we have the invention of electricity in the late 1800s. So with the invention of electricity, so we have the industrial revolutions. So the industrial revolutions, the industry revolusi industry, as we call it in Malaysia, we have a lot of opportunities. We have a lot of opportunities in terms of manufacturing, in terms of putting up new inventions, one of the invention which is very important is the invention of telephone and telegraph, which become the basis of the internet communication nowadays, So when we have these internet communications, which is invented, around 1960s, in the 60s. So we have what we call this reliable communications that connect the human and the things, we are able to connect people, we are able to connect machines, in the distant land, with a very, very fast communications, and this happened also with the advent of what we call the telephony, the telecommunication networks, and the switching technology, for example, allow us to connect with ease, yeah, to other part of the world. And then now we are moving, yeah, I say here beyond 2023, yeah, it is which is beyond, which is a post-COVID era. So we are moving toward what we call it the intelligence connectivity, yeah, the connected intelligent world, yeah, where the intelligence drive the global economy, yeah. So we now use, for example, ChatGPT. We use all those big data analytics tool, yeah, and we use advanced communication networks to work together to actually drive our future, our life, our economy towards in the future. So we are going to talk about these implications in the next lecture. But in this lecture, we will be talking more on the IoT and the 6G, inshallah. Yeah. So first, towards having the connected intelligence, so we have the concept of all things sense. Yeah, we have put all senses. Yeah, we put all senses here and there. Yeah, even on our bodies. Yeah, for example, we wear our smartwatch. Yeah, we wear our trackers. Yeah, we wear our for example, those patients, diabetic patients, for example, they are using what we call it the glucose monitors, yeah, which sense the level, the change of level in the glucose level, the blood glucose level in their bodies, and then send it over the internet, yeah, to be processed, yeah, to be presented for to doctors and so on. So sensors are everywhere, and it sends not only the temperature, the space, yeah, but it also sends now the smell, and people are now trying even how to sense the smell and replicate it on the other side. So this is a very nice thing to do if we can do it, yeah. And then the next thing is we have all things connected, yeah. Not only we have the sensors, we have these devices, yeah, that we put in cities, for example, yeah. Probably you may have heard about the project, one of the Chinese project called the Smart City Brain project, yeah, where I think Jakarta is also involved. Kuala Lumpur is, I know Kuala Lumpur involved in this project, where they installed the sensors, yeah, the monitors, the cameras, whatever on the city streets, yeah, and also on the communications infrastructures, so that they can get the data and then process the data, yeah, upload the data and process it in China, and then send it back to the decision makers in Malaysia. I know this is a very big sensitive in terms of privacy, but it also helps in terms of city planning and so on. So back to the everything connected. Yeah. So we not only we have sensors everywhere, all these sensors are connected. Yeah. The data goes online, and when the data goes online, it can power the what we call the machine intelligence. Yeah. So we have the ubiquitous. Ubiquitous means everywhere, every time that we need it. That sends the data, big, huge amount of data to the central server, for example, and then we process it. And the third thing is everything intelligence. Yeah. So now we are moving towards the intelligent network. So with all this intelligent network, we have the data sensed by the sensors, all the IoT devices, using the machine-to-machine connections, device-to-device connections. We get the data, we process the data, and we have what we call the integrated intelligence. And this integrated intelligence powers the new applications. So this will change how we see the computing environment in the future. Yeah. Now we have simple AI. Yeah. For example, the generative AI. Yeah. I've been, in my career, in my process of learning, I learned AI when I was in the States, in America, a long time ago, in the 80s, yeah, about the artificial intelligence. And then, but it doesn't, it doesn't give the much impact like we have today. Yeah. So today we have, when we have the advance of the machine learning, yeah, and then we come up with this generative AI, yeah. So all these things will go towards what we call the artificial general intelligence, which is very, very intelligent in the future, that will create a new environment, yeah, for us to operate, yeah, for us, the human, to operate, yeah. And all these things, yeah, are supported by various communication technologies, yeah. We have the broadband connectivity, yeah, the broadband connectivity. What is broad, what is not broad. This is also interesting. Yeah, when I was a student a long time ago, in over 40 years ago, I have one of the fastest modem that I used to connect my computer at home to my university in New York, and I was studying in New York at that time, and the speed was only 2.4 um, 2,400 bit per second. Yeah, 2.4 kilobit per second. Yeah, so can you imagine we can do the communication at that time with only 2.4 kilobit per second. Yeah, but now we are communicating in megabit per second. Yeah, and even faster. And toward the 6G, we will be communicating in the terabit per second. Yeah. And then we have also smart devices. We have data centers. Yeah. These are the important development nowadays. Yeah. We have data centers, for example, mushrooming around the world. Yeah. I'm sure you have heard that Google's also expand to the Asia Pacific, having data centers everywhere, including in Malaysia, for example. Yeah, and this will allow the data to be processed faster, and the delay from the users to the data center or from the IoT device to the data center will be less and less, and this will make the processing become better. Yeah. And then we have the advance of what we call the cloud, the fog computing, the edge computing, and this is the computing paradigm that allow us to store our data, yeah, in the distributed manner, in the large quantity of data, and for the processing. Yeah, this is very, very important. And we will be talking about how important is the edge technology in the 6G network. and now also becoming important the edge technology, yeah, in the 5G networks, yeah. And then we have the advanced data analytics, yeah. We have the big data, yeah. Big data, how big? It's very big, yeah. We have all the data that we collect nowadays, yeah. Even, for example, the communication on WhatsApp, for example, billions of people are using WhatsApps. And this billion of people communicating through WhatsApps generate, I would say, zettabytes of data, yeah. And this data is very, very much valuable, and it becomes the commodity of the future, yeah. The oil of the future, yeah. If we think that the oil is very much valuable nowadays, and the future, the data will be much valuable. So data analytics is important, and we will see next week, inshallah, how this data generated by IoT and so on will be processed, yeah. Supporting by the 6G communication network will be processed faster and efficient in the smart environment. And then we have the IoT and robotics, definitely. This is what we are talking today. Some people say there's this robots will replace the human. Yeah. Well, depending on how you look at it, it is true or not true. But that depends on our how we perceive this claim. Yeah. But IoT is everywhere and robot is everywhere. Now you can go to the restaurant and it will be served by the robots. Yeah. And somehow people say that you can take your wife, a robotic wife, but that is too futuristic. Yeah. Whatever intelligence that they have, they cannot have the soul. Yeah, this is what I believe. Yeah, Dr. Agus, whatever that the intelligence that they have, they don't have the soul like the human. Yeah, and then the last thing, what supports the intelligent environment, I would say, is the artificial intelligence. Yeah, artificial intelligence. So this intelligence is in our language, we, some people say kecerdasan buatan, some people say kepintaran buatan. What in Indonesia, what terms we use? Is it
Kecerdasan buatan.
kecerdasan buatan, ya? Kecerdasan buatan, ya?
Yes.
It all means the same, ya. Pintar, cerdas, ya, cerdik, ya, dan sebagainya, ya. All right. So this three technologies, I would say the IoT, the big data, and the AI are the core elements of what we call the intelligent network computing environment. Yeah. So these are the technologies that form the powerful ecosystems, yeah, in creating opportunities in health, in education, transportation, and you name it, what domain that we want. So everything need to be smart. Everything need to be intelligent. Yeah. So in this context, we have the IoT devices. Yeah. So these IoT devices generate massive amount of data, and this massive amount of data fuels the AI algorithm. Yeah. And these AI algorithms makes our world more intelligent, yeah? And we have more automated systems, and these automated systems will automate the processes, yeah? And most importantly, automating the processes closer where the data is created. Yeah. And this is leading to what we call the age of the network. Yeah. Having this edge computing will make the processing very fast, very efficient, and low delay. Yeah. So what we will be exploring in both of the sessions. So we are exploring the future of global communications as we move into intelligent network in the 6G era. So we will look briefly about what we have at the internet with the internet technologies that have changed the communications in the 21st century. So we will see the convergence, yeah, of this IoT, the big data, the artificial intelligence into the future of the 6G network environment, and how the 6G network environment will help us, yeah, in our life, especially in our economy, yeah, like healthcare, like manufacturing, transport, and so on. Yeah. And I hope in next week we also talk the implications on cybersecurity, on data integrity and trust in this hyper-connected world. Yeah. And the ultimate goal, yeah, for this lecture, for these two lectures, is to understand how this technology drive the innovations and address the global challenges. So let us, I will be spending more in talking about the internet technologies and IoT, because this is the core, I would say, the core of our lecture. Yeah. So as we understand, as we realize every day, yeah, when we wake up in the morning, yeah, some people, they forgot to make a prayer in the morning. What they do first is grab the handphone and probably look at the handphone first, yeah, get the message, yeah. This is possible, this is made possible because we have the internet technologies. The internet technologies has transformed the 21st century, yeah, communications into what we call a single IP networks. Yeah. So everything is connected through IP world, yeah, the internet protocol, yeah. The internet protocol, everything. Now we have voice, we have video, we have audio, everything works, yeah, into the internet protocol, yeah. What we call the single IP networks with separate services, yeah. So then what is Internet of Things? Yeah, simply Internet of Things refers to the communications from various things over the internet. Yeah, but IoT may be provided into in the private network as well, not only in the public IP networks. Yeah, so we can say that we have the global public open IP networks that support the IoT, and we can have also the private networks, yeah, that able to run the IoT applications, yeah. So there is one organization in the world which is very, very important in data communications, in telecommunications. It's called the ITU, yeah, the International Telecommunication Union. So the International Telecommunication Union is the oldest United Nations agency, yeah, is the oldest United Nations agency, an agency under the United Nations. Yeah, nowadays they have the United Nations General Assemblies, yeah, going on. So ITU, International Telecommunication Union, is responsible for governing the telecommunications and ICT around the world. In addition, this is a membership type of organization. So Indonesia is a member state of ITU. Malaysia is a member state of the ITU. So ITU come up with the definitions of the Internet of Things. So what ITU says here is that the Internet of Things is the global architecture, global infrastructure for the information society that enables advanced services, by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technologies. So what we can see here, the emphasis on the information society. The information society is a society that uses the informations that drive the world today. So IoT, from this definition, enable the services by interconnecting physical and virtual things. So what is virtual things? We know the physical things. What are the virtual things? That exist. For example, nowadays we will have the network slice. For example, the services of telecommunication is put into different network slices made of different frequency spectrum, for example, and this is connected to the users, to the servers, for example, through the IoT. So this is what we mean by the virtual things. Virtual environment, for example. The virtual environment. So we have for example, the two virtual environments connecting together through the IoT network. So why is it important? I need to put this fact. I would say in 2025, the predictions of IoT in 2025, to highlight the importance of IoT. So otherwise we don't appreciate the importance. So the global connections will be about 27 billions. So 27 billions are devices connected to the internet. And this increase, 10 years ago, we have only 6 billion. And these connections generate the revenue forecast for 2025 of 3 trillion US dollars. 3 trillion US dollars. So to convert it to Indonesian rupiah, we need to multiply by a certain number. So definitely, I do not know how to pronounce the number in Indonesian rupiah. So it is a huge amount. Even in the US dollars, in Malaysian ringgit, it is a very huge amount. It's 3 trillion. And that also involves the connections. The connections. Nowadays, the connections will rely a lot on the cellular connections. We have more cellular phones, for example. And cellular connections will be 2.2 billions. When we go to Indonesia, for example, last week, so my boy got, my son got a new SIM card, put it into the mobile phones, and automatically that's generate one connections, one another opportunity for connections. Yeah. So we have 2.2 billion connections, yeah, compared to 334 million, yeah, by the end of 2015. And not only that, we have, in terms of transportations, we have cellular IoT connections in connected cars. Yeah, we have nowadays smart cars connected through IoTs. Yeah, and zettabytes of data generated by these IoT devices. So we are living in the era where IoT is important, and it continues to be important as we go toward 2020. We go toward the 6G network. Yeah, 6G wireless cellular network. Yeah. So this is also a favorite diagram that I show, yeah, to show a smart city scenario, yeah, and this is implemented everywhere nowadays, yeah. We have various sensors, yeah, in the cities, yeah, to measure the air pollutions, yeah, to measure, for example, radiation level, yeah, to deal with traffic congestions, yeah, the EM, yeah, electromagnetic levels, yeah. We have the smart roads, yeah. We have the measure of traffics, yeah. So, for example, the integrated application of this, for example, when we have congestions in the networks, so it will relay, yeah, to the for example, for the airports, yeah, for example, to delay the departure and so on. Yeah, this is happening, yeah, everywhere. Yeah, we have, for example, the seismic sensors that sense the seismic the movement of Earth, for example. Yeah, that will alert the people to be ready. Yeah, we have the sensors, for example, the tsunami sensors, for example. Yeah, what happened? Yeah, we put the sensors in the sea, yeah, to see if the tsunami is coming. Yeah, we have all the sensors, these IoT sensors, to work in this context. Yeah. So we have, when we talk about IoT, we have also another terms, yeah, that is, I would say, conveniently used, yeah, in these discussions, which is called the M2M, yeah, the machine to machine, yeah, device to device, yeah, communications. And what is the different with IoT, yeah? So it is related, yeah. So machine to machine refers to the direct communications between machines or devices, yeah. And this is normally point to point communications using cellular, yeah, using wired, yeah, or using satellite links, yeah. And M2M, machine to machine, is normally purpose built, yeah. For example, we have smart meters in the house, so that the meter, the electricity meter in the house will connect to the electricity company, yeah, to tell what is the usage and so on, yeah. And then we have the IoT, yeah. So the IoT actually connects the devices to the internet. So the M2M is the communication in general between two devices. So the IoT, when we talk about IoT, is having the M2M is connecting through the internet, using the internet technology, yeah. So we can have the Wi-Fi, we can have the 5G, yeah. the low powered WAN, yeah, for example, the LoRa WAN, low range WAN, and so on, yeah. And the data using the IoT will be shared through the clouds, yeah, the AI systems, and this is highly scalable. Yeah, the IoT is very highly scalable, meaning that it can grow. Yeah, it can grow. So M2M is device to device. Yeah, IoT is device to cloud to anywhere. Yeah. So in summary, yeah, the IoT builds the on M2M, but adds internet connectivity to M2M. So when we have the internet connectivity, we can scale it up or scale it down. We can do data analytics and so on. And the next thing to say, to mention here is what drives the IoT. Yeah. So there are three things that drive the IoT. Yeah. So we have the connectivity, we have the sensors and actuators. Yeah. And we have the processors and also users. Yeah. So here we have all kind of sensors. Yeah. For example, if you have iPhone or Samsung or Huawei, yeah, whatever. So on Samsung, on iPhones, then you have maybe, you know, without realizing it, we have the sensors, the location sensors, yeah, the camera sensors, your proximity sensors, and so on, yeah, on the iPhone, yeah. So sensors and actuators we can have, for example, the temperature sensors, yeah, the vibrations, yeah, the flow sensors, and so on. And then we have the connectivity, yeah. So the connectivity, we have a range of connectivities, yeah, from the short range connectivity. We have wired connectivity. So for example, nowadays we can use a power line connectivity, yeah, connectivity through using the power line. But our interest here is on the cellular, yeah, because when we talk about 6G, yeah, this is the evolutions of the 3G, 4G, 5G network, yeah. So we will talk about the cellular networks, but we don't want to miss other important technologies in the IoT, yeah. For example, in the personal area networks, yeah, we have, for example, the ZigBee, yeah, we have the Bluetooth, yeah, we have LAN, yeah, local area network, we have metropolitan area network, yeah, we have wide area network. So all of these are supported by the cellular communications and connect the cellular communications, yeah, and connectivity is supported by the radio spectrum, yeah, and then we have the licensed spectrum and also the unlicensed spectrums. Yeah, the unlicensed spectrums we can use freely without being regulated by the government. Yeah, for example, we use the Wi-Fi. Yeah, Wi-Fi in our house. It is not regulated. Yeah, directly by the government on the spectrum use. So spectrum is more freely used in the Wi-Fi, for example, in the Bluetooth technology and the Z-Wave technology, for example. Next, we have the people and the process. Yeah, so the people and process are the things which is important for the IoT. Yeah, we have the customer relationship, for example, the location tracking where we put the trackers on our trucks, on our fleet. Yeah, for example, yeah, on our cars. Yeah, the financial process. Yeah, the configurations, the updates that we do. So these are the processes. Yeah, for example, how do we update, for example, the IoT devices? So definitely it needs to do the configuration updates, yeah, through networks, yeah. control, the automations, yeah, security, energy, and so on. So all this leading to the wide usage of the IoT, yeah. So we have sensors, actuators, we have communications, we have people and processes. All this leads into the wide use of the IoT, yeah, in home consumer use, yeah. For example, we have these light bulbs, yeah. Nowadays, we have smart homes, yeah. We have transport, mobility, yeah. We have health, body. Nowadays, like I said, the glucose tracker, for example, yeah. Previously, we need to, for those who have diabetic, yeah, kencing manis, yeah, in Malay. Um, we previously we use the glucose, yeah, to prick the finger, yeah, and then we read it manually. But nowadays we can have the automated trackers, yeah. We have the small implant to our uh, um, leg or somewhere, arms, yeah. And then we can have the glucose level transmitted to our handphone, yeah, to the server, yeah. And then we can access, yeah, the cloud, yeah. We can have it monitored every 5 minutes and so on. So this is in terms of health. In terms of building infrastructure, we can detect for example, the air conditioning, yeah, security, lighting, electrical, and so on, as well as the cities, as I mentioned before. So again, I want to mention about ITU because when we talk about IoT, it is made possible with a concept called convergence. Yeah, the convergence of the telecommunications and the internet. Yeah. So how this convergence started? Yeah, it started when in the 2000s. Yeah, the ITU, the International Telecom Union, introduced the concept of what we call the next generation's networks. Yeah, and next generation networks combine the telecoms and internet networks. Yeah, so with these combinations, the applications of IoT also become wider. Yeah, so this is possible through the use of the transport layer. Yeah, the transport layer here is the layer which is responsible to move data. Yeah, like switches, routers. Yeah, so we have in the diagram here, you can see we have the NGN layer. Yeah, the service layer, the transport layer. Yeah, that move data from this. Routers, yeah, and switches, yeah. And then we have the service layers, yeah, the service layers, yeah. So service layers provide the service. We have the database, yeah. We have the apps, yeah, and connected to what we call the USN, yeah, to the ubiquitous sensor network, ubiquitous sensor networks. So we call it ubiquitous because it is everywhere. So sensor collects the data from the environment, and the data is shared over the networks, yeah, and the knowledge and services can reach everyone, yeah. And this is actually the NGN framework introduced by the ITU, yeah, that supports the IoT, yeah. So I mentioned this because this is the basis of the convergence of telecommunication and the internet, which enable the IoT to be deployed widely. Yeah. And as I said, in this convergence world, it is actually digitalizing the telecommunication network. Yeah. Originally, telecommunication network carries only phone calls. Yeah. But nowadays, it carries data from sensors. It carries voice, yeah, from our mobile phones and so on, yeah. And this carries the data not in the analog mode, it carries in the digital mode, yeah. And I want to mention here, we cannot leave this from mentioning. I cannot forget this. Yeah, I have to say this because when we talk about IoT, it's about internet. Yeah, when we talk about internet, there are two two important protocols in the internet. Yeah, that sends the data in the internet. Yeah. Which is we live every day. Yeah. One is what we call the TCP. Yeah, the Transmission Control Protocol, and another one is called the UDP. Yeah. So TCP is a very what we call heavy protocol. Yeah, is a good citizen protocol. Yeah. So every time you need to communicate. Yeah. The device need to do the handshake. Yeah. Give the salam, yeah, assalamualaikum, I want to communicate, yeah, do the handshake, and then only you do the communications. Yeah, when the device is sending huge amount of data, another device will say, hey, I cannot receive the data. So the sender will slow down. So this is what we have in TCP. But we have another protocols called UDP. Yeah, UDP stands for User Datagram Protocol. So User Datagram Protocol is a protocol, transport layer protocol, which is very fast. Yeah, it doesn't use protocol. It doesn't use. I would say not. I'm saying again, it doesn't use rules like TCP. Yeah. Whenever it has data to send, it can just send. Yeah. Without giving the salam, without establishing the connection first. And this is good, this is bad. Yeah, good thing is that it is faster. Yeah, the bad thing is that you don't have the reliability in UDP. Yeah, so this also impact how we use the future internet technologies like the IoT. Yeah, so let's say here we have a diagram here. So we have the TCP. Yeah, TCP is whenever you want to do the communication, it has to establish a connections. Yeah, and then the receiver will have to respond to the sender, and then all and on and on until the communication is set up. So, yeah. So and then the security level as well. Yeah. So with the security, it adds more delay to the communications. Yeah. But with new protocols, yeah, the QUIC, yeah, the QUIC is a new protocol nowadays. Yeah, in addition to TCP and UDP, yeah, the IETF, yeah, Internet Engineering Task Force, come up the new protocol called QUIC, and this QUIC is, has a potential to be used for the IoT services. Yeah, because it is good for both worlds. Yeah, it is not as rules intensive like TCP, but it is not as lenient as the UDP. Yeah, but it is fast. Yeah, it can have very low latency delay, and this is good for sensor communications. Yeah. So the HTTP 3.0, for example, yeah, the HTTP protocol is a protocol that we use every day. We use HTTP 1.01, we use HTTP 2, but HTTP 3.0 will be optimized for the IoT communications, yeah, because it supports, yeah, the QUIC, yeah, the QUIC protocol, yeah, the QUIC protocol is a protocol that is a merger between TCP and UDP. Yeah. Other protocols we have other than TCP, UDP, we have so many protocols, hundreds of protocols. But most important protocols that I want to highlight here, we have SMPP, yeah, which support the instant messaging, yeah, over the IoT, yeah. So we have also MQTT, yeah. So MQTT is used, yeah, for mostly for the telemetry transport, yeah. So we have MQTT implemented, so it can be the linkage between the sender and the receiver, yeah. And then on the web, yeah, we can have the REST, what we call the representational state transfer, the REST protocol, yeah. So the REST protocol is used for what we call the web of things, yeah. IoT for web services or web of things. And we have also another protocol called CoAPS, yeah, Constraint Application Protocol, yeah. And these are all the protocols, yeah, which is important. I don't highlight it very detailed because of the time consuming. Yeah, I hope that we can have more sessions on this. It can be covered in the classroom as well. And then before we go to the 6G, yeah, I just want to highlight several IoT standards. Yeah. So why IoT standards? Yeah, because IoT standards are, when we call standards, it is actually the governance of the technology, so that when people follow certain standards, then things can be easily managed. Yeah. So it's like if you open up the tire is in Indonesia they call ban, yeah. Tire. If you build a tire without following the standard, then the tire cannot be fit into a certain model of the car, for example. So standard is very important in IoT, yeah. And the standards for IoT, there are many standards, yeah, that governs IoT, yeah. We have the short range technology standards, and this short range technology standard connects the personal environment, the home, the indoor applications, and there are also long range technologies, yeah. So this long range technology connects outdoors to things that is in outdoors, to the gateways, to the hub, yeah, to the global telecom or ICT networks, yeah. And some of them uses internet technologies, yeah, IP networks. And we have in the past also people use the proprietary protocol, yeah, proprietary protocols, yeah. And then we will have the IoT standards will survive towards 2030, yeah. And those that need to survive beyond 2030 will have the two characteristics. One is what we call convergence. Another thing is the interoperability. Yeah. So they must converge. Converge means they need to be used on the IP single IP networks. Yeah. So when it needs to converge, it can support, yeah, the communications between telecom world and also the internet world. Yeah, that is what we mean by converge. Yeah, and interoperability means that it can be interoperable. It can work in various environment with various devices. Yeah. And this is important, yeah. When we talk about going toward 2030, we are talking about when the 6G environment will arrive, yeah. So this is the thing. So when we look into the general IoT network architecture nowadays, yeah, so we have the sensors, actuators, like I said, yeah, connected in short range to Wi-Fi, for example. And then we have Bluetooth, we have the 4G, 5G, and later we will have 6G communications. We have a gateway, industrial gateway that connects a Wi-Fi, the GSM, the low, the older generations of cellular networks. We have the Sigfox technology, for example, the LTE, the 5G, yeah, connected through the wireless and connected to the satellite networks, for example, yeah, and this is connected to the internet, yeah, or the managed IP networks, yeah. So the word managed IP network is important work nowadays, important words nowadays, yeah, and and all these are connected to the IoT cloud, yeah, where intelligence and data analytics, yeah. So when we talk about IoT, it is heterogeneous, meaning that um, kepelbagaian, ya, kepelbagaian, various aspect of kepelbagaian ini, ya, heterogeneous, ya. Um, Heterogeneous is the opposite word of homogeneous. Homogeneous itu seragam, ya. Kalau heterogeneous itu adalah kepelbagaian, ya. So we have low cost, low cost sensors. We have the high cost IoT, for example, transportation vehicles, the low power versus high power, low power, for example, actuators, or high power, high power. We have the robots, in the factory with motion control, we have long battery durations, versus electricity network, long battery durations. We have sensors that is very long, For example, I said the glucose sensor, for example. I'm diabetic patients, So the sensor normally work for 2 weeks, So after 2 weeks, you need to put another sensor, So the battery dies away, high number of connections, versus a small number of connections, For example, we have the critical services IoT networks, low bit rates and high bit rates. Low bit rates, we have, for example, sensors. High bit rates, we have cameras, for example, video surveillance connected to these IoT devices. We have also IoT device which is in long range versus short range. Long range, covering tens of kilometers away. Short range in office, halls, and home. Low processing versus high processing, sensors, actuators for low processing. High processing, we have the critical IoT in the smart factory. We have the automations, we have also low storage capacity. For example, the sensors and actuators, we have low storage, and also we have high storage capacity. For example, for the video surveillance, augmented reality log recordings, we have small devices and large devices, small devices, we have the sensors, large device, we have vehicles, we have drones, drones, simple networks, sensors, complex networks, we have the IoT networks in general, that requires the quality of service, So this is the how IoT kepelbagaian itu pelbagai, diverse of IoT characteristics, So let's look into the first IoT group. We have the RFID, So nowadays, RFID is everywhere, For example, the parking parking stickers, yeah. We have tool, yeah, the tool systems using the RFID, yeah. So this RFID devices is connected to the IP networks, yeah, through the RFID tags, yeah, and the tag, we have the sensors that read the information in the tag and pass through the network, yeah, and then for the processing, and then we have the results, yeah. And then we have the Bluetooth, yeah. The Bluetooth is used for the short-range IoT technology, yeah. So we have two modes of Bluetooth standards, yeah. The Bluetooth Classic, yeah, we have for the audio streaming. We have also Bluetooth Low Energy, yeah. We have Bluetooth Low Energy for low power IoT services, yeah. So this Bluetooth enable the IoT communication in short range, and the data rates is about 1 megabit per second and above. Yeah, it supports low latency, and it is used in various places in our cars. Yeah, in the house. Yeah. And the spectrum is unlicensed. Yeah, it's not regulated. Then we have the mesh Bluetooth. Yeah. It's quite recent, yeah, in 2017. So this will enable our communications with various devices, yeah. For example, we can have various sensors and actuators connected to the mesh, and then this mesh is connected to the gateways, and then to the internet, yeah, to the internet. So this can support various applications, yeah. For example, to check the humidity, temperatures, yeah, the carbon monoxide, for example, and then this is used widely nowadays, yeah. And then nowadays, when we have the cellular IoT, yeah, the cellular IoT is supported, yeah, in the LTE world, starting from the 4G networks, yeah. So we use the Bluetooth with cellular IoT, yeah, to minimize the operational costs, yeah. And through this we can have the narrow band, yeah, through narrow band, also the LTE. LTE is the 4G cellular network, yeah. This enable the sensors to be connected through the gateway and through the cellular network, yeah, to the processing, yeah. And then another important standard for IoT is ZigBee. Yeah? So ZigBee is based on the IEEE 802.15. Yeah. So as you notice here, 802 family is actually the family of the local area network. Yeah. The family which is of the IEEE standard, which is govern the local area network. Yeah. So ZigBee is used for the low-cost, short-range IoT technologies. Yeah, that connect various devices. Yeah, in the short-range terms, and this is connected through the what we call it, through sort of local area connections. Yeah. And then we have the Z-Wave technology, yeah, which also the technology to connect the low power and low cost devices, yeah, For example, the light dimmers, temperature sensors, door lock, So this D-Wave technology is also used for the indoor, can cover 30 meters indoor and about 100 meters outdoor, which is considered a very, very short range communications. And then this is the comparison between short range and long range radio technology. So we have Wi-Fi as the, with more data rates here. And on the range, we have, for example, the 5G, the 6G, on the shorter range, we have Z-Wave, the Zigbee here, and we have Bluetooth on the lower range, and we have the GSM, GPRS, and on the long range, So we have also IoT devices, that is using LoRaWAN, LoRa is the long range wide area network, it's a private IoT wireless network, that connects in the long range network, devices in long range network. So it can be covered in 15 kilometers, for example, And then this is some examples of LoRaWAN use case. We have the smart industry, smart agriculture, we tag the cows and so on, smart cities, smart utilities, logistic, asset tracking, supply chain, smart buildings, And we have a new technology called Sigfox, which is a low-powered technology for IoT, which is ultra narrow band, low throughput, extended range, up to 50 kilometers, this is Sigfox, which is considerably new technology, Okay, I think Dr. Agus,
Yes.
Pak Agus, we have 5 more minutes to go. What if I instead of putting to the 6G, can I use these 5 minutes to answer any question if there are any questions?
Yes. Yes, Prof. Swedi, thank you very much for 85 minutes, the insightful, interesting presentation. Now I think it's 5 minutes for Q&A. It is enough. Then maybe we can collect any question if there are more questions from another students later, and then we can answer in the next
Session.
next lecture next week.
Yes.
However, we have 5 minutes. Any question, students? Yes. Okay.
I'd rather use English. So, Mr. Suhaidi.
Yeah.
Professor Suhaidi, I have one question. So, in the revolutionary of machine, there's a lot of workers get easily replaced by the machine. Now it's IoT, whereas there's a lot of there's a lot of job could be easily replaced by this IoT. So, for examples, like Internet of Vehicle. Now you don't have to hire a machinist to run a train, or maybe you don't have to hire some taxi driver to drive the car, because cars now drive by itself. So what do you think is the best thing that we have to do to avoid this big wave of unemployment in the future? I think that's all. Thank you.
Yeah.
Okay, I think one question for now, please, Prof. Suhaidi. Any?
This is a very good question. This is a worry of everyone's. Will all this automation replace the human in the future? So it depends on how we look at it. Yeah. This is how we need to enhance our thinking level, enhance our skills, for example. Yeah, because what we call the 3D jobs. Yeah, the dirty what we call the 3D, the dirty the those who need the power intensive. Yeah, the dirty, difficult, and another one is dirty, difficult, and everything will be covered by automations. Yeah, but definitely these are good for the machines to do, but there are things that they are not good for the machines to do. For example, in terms of design, for example, yeah, in terms of design, probably we can automate certain design, but we need the human touch. Yeah, as I said, yeah, the things by the machines, they can do a lot of things in terms of automating the thing, and this will lower the cost. Yeah, but the human is still in need. Yeah, for example, the machine will not be able to implement, for example, something artistic. For example, artistic. Yeah, artistic. The human have the ingenuity that is more needed in the area of, for example, high cognition, for example. Yeah. Don't worry, even though the machine will be replaced. Yeah. All these factory workers. Yeah. Yeah. If you read the Xiaomi cars. Yeah, they produce a car in uh, one car in less than 60 minutes, 60 seconds. Yeah, I heard. Yeah, definitely. When the demand is there, yeah, for the cars to be produced fast, even a human cannot produce it fast. Yeah, so we will need robots and so on. But definitely, for example, some expertise, for example, will you allow robots to operate your brain? Definitely we will not be allowing the robots to operate. At least myself, I don't allow the robots to operate my heart, for example. Yeah. So you need the human hand there. Yeah. This will require the skills. Yeah. And also the human connections, the level of knowledge that we can have. And this is an opportunity for us. Yeah. The humans. So this is the war with the machines. Yeah, human with the machine war, and I still believe the human will have the upper hand. Pak Agus, ya, Dr. Agus.
Okay, thank you very much, Prof. Swedi. I think it's enough for now. Probably if a student has the question, we can collect it. Maybe we'll submit to Prof. Swedi. Okay, the last time we give a big applause to Professor Swedi.
Prof, Dr. Agus, yeah. Maybe I want to highlight what we want to do next week. Yeah. So next week, having known about the IoT background this week, so next week we will be covering about the 6G. So what are the characteristics of 6G and how the 6G will be used, and what are the implications? Yeah, as what our friend asked me just now. What are the implication of 6G? And this is going to be very interesting as well. Yeah, I hope I can cover it very fast, because it has a huge number of materials, to cover. Yeah, it's like IoT. IoT is, I skip a lot of slides even, yeah. to cover this IoT today. But I hope I can cover it very fast next week about the 6G. So saya mohon maaf di atas segala kelemahan sekiranya ada, and thank you very much for your attention, and insyaAllah we will see you again next week at the same time, ya, Dr. Agus, ya.
Yes, insyaAllah.
Thank you very much.
Thank you very much. Ya, Assalamualaikum warahmatullahi wabarakatuh, Prof. Suhaidi.
Waalaikumsalam warahmatullah.
Oke, baik. Sebelum kita akhiri, yang tadi ada tanya. Oke, ya baik. Terima kasih sekali buat atensinya. Ya, nanti saya cobalah Anda nanti bisa mereview ya sebagai tugas, karena saya pikir ini juga suatu topik bagus untuk topik materi kita ya. Sebagian sudah saya berikan, tapi ada bagian yang lain yang mungkin menjadi insightful bagi kita ya. Dan insya Allah kita menurut saya sih mendapat benefit yang cukup bagus ya. 6G kemarin sudah saya ceritakan sedikit, very light. Hopefully next week we can obtain more information, more material. I think it's good for us. Oke, terima kasih. Saya tutup sampai sini. Insya Allah kita waktu minggu depan di ruang yang sama. Assalamualaikum warahmatullahi wabarakatuh. Bagus suaranya, Mas. Ya, makasih ya, Pak. Ya, di sini yang mahal. Makasih, Pak. Ya. Makasih, Pak. Ya. Ini kan sampai tanggal 29 ya. Nanti kita di minggu depan kita sih. Iya, silakan. Kali ya. Oke. Tapi ini kan setting ini juga nggak lama, udah biasa aja. Iya. Lagi awalnya yang juga semua. Kan kita punya dua terus. Ya. Apa itu kok begitu pas dengan satu tapi ada yang orang aja. Iya kan? Ya. Apa namanya? Oh ya. Oke. Sama iya Pak, nanti nah, tapi adalah ini penasaran kita coba dicek GPT Zero ya. Itu ke 70% Pak, padahal saya ketik mandiri itu ya kan kemarin saya lihat bukan masalah AI, saya lihat ada yang ya terserah pada sesuai dengan sistem Anda itu kan sense-nya itu adalah tentunya ChatGPT. Kalau Anda selama ngetik sendiri, kemudian diskusi ya, yang bisa tambahin, ya lah. Tapi itu kan kemarin saya lihat ada yang saya baca ada hanya ngopi dari ChatGPT. Dari bahasanya kelihatan, bukan bahasa dari apa yang ada. Berarti sama saya ketik mandiri aman berarti. Aman. Saya lihat baca satu-satu ya. Wah ini ChatGPT benar. Boleh menambahkan, tapi jangan lupa banget. Kalau misalnya ChatGPT yang bisa saya bantu ini ya tergantung dari sistem kamu yang kamu gunakan itu kan satu bahasa kita.
Soalnya takutnya saya kan ini apa nggak pernah pakai ChatGPT sama
Ya.
sekali, takutnya saya nah
Tidak
tetangga juga.
apa-apa, kalau bahasa sendiri saya pikir oke. Jadi bantu oke, tapi jangan semuanya. Cuma dia kelihatan banget saya bisa tahu.
Ya.
Karena itu bukan bahasa ngobrol kita, tapi bahasanya ya salah jadi. Ya, oke ya.
Berarti untuk saya insya Allah aman ya Pak.
Ya, yang penting adalah Anda merusuk dari apa yang Anda baca di bawah, bukan dari ChatGPT. Itu sudah bertugas itu benar. Ya, gitu ya. Oke.
Ya. Makasih banyak ya
Yo,
Pak.
ya,
Makasih Pak.
ya.
Makasih Pak.
Yo. Oke, saya. Iya, Pak. Betul ada tempat yang bagus ya. Oh iya, Mas, nanti kami sih komputer ini ya. Kamu sih kami satu lagi. Siapa masukkan? Jadi tanya-tanya.
Saya ngebut yang ini dulu Pak, pengadaan.
Gak apa-apa ya, pengajian.
Tapi Bapak juga sebenarnya.
Ya.
Biasa aja sih.
Untuk apa? Ininya ya, bisa pakai kan?
Iya, betul.
Oke.
Terima kasih Pak Agus.
Ya, sama-sama saya makasih ya. Ini tugas dari fakultas ini.
Sudah dapat itu Pak.
Kenapa dari sisi itu makanya sisi tapi mungkin nggak banyak ya. Berapa dulu mungkin 4 gitu loh. Saya tinggal dulu ya Mas, makasih ya Mas.